Live from the BBC, The Naked Scientists.
A very good evening. Welcome to this week's edition of The Naked Scientists with me, Dr. Chris Smith, and with Dr. Catherine Hawkins, who's also here to present tonight's show. Good evening, Catherine.
Hi there, Chris.
Well, coming up tonight, we have an explosive show for you for Bonfire Night, because it is the 6th of November, and we're going to be discussing the science of fireworks and the science of November the 5th. And here to help us do that, we have chemist and prize-winning author Dr. John Emsley. Good evening, John.
Good evening, Chris.
John's here to take any question you'd like to ask him about how fireworks work, how explosives work, the chemistry behind fireworks. So perhaps you've been to a display this weekend and you thought, well, that was a fantastic firework. How did they do that? How did they make those amazing colours? How did they create those special effects? If you'd like to know those questions or have them answered for you, 08459 25 2000 is the phone number to call us in on. 08459 25 2000. Also joining us this evening, Jacqueline Ackervan, who's also an expert on explosives and pyrotechnics. She'll be on the telephone later, and she can also take those kinds of questions. So call in if there's anything you'd like to know about blowing things up, basically. Now, talking about blowy things, coming up this evening, we're going to find out what it is like to go into a hurricane on an aeroplane. It sounds pretty mad, but it's going to happen, because we're going to be talking to Mark Strope, who is a journalist from the US, and he flew on an aeroplane right into the heart, right through the eye of Hurricane Rita. He's not mad. He survived the journey, and he's going to tell us what it was like to do that and why he actually went through that experience. Also, our regular feature, Kitchen Chemistry. Waiting in the kitchen, Derek and Dave are with Sam and Sebastian at Ecton Brook in Northamptonshire, and they are going to be making a homemade fire extinguisher. Perfect for November the 5th, of course. And so if you'd like to have a go at experimenting alongside them, they're coming up very, very shortly. You're going to need some simple ingredients. You're going to need some acid, so vinegar is a perfect choice for that. And you're also going to need some baking soda or some bicarbonate of soda. If you get those two ingredients to hand, Derek and Dave will tell you very, very shortly what you need to do with it. And if you're the first person to discover the chemical reaction, you could win yourself some fantastic prizes. That's not all we have in store for you this evening. Here's Catherine with a rundown of what else to look forward to. Catherine.
Yes, exciting stuff, Chris, and I'm sure if it gets a bit hot in the studio, that fire extinguisher will be useful. In this week's news stories, we'll be finding out about how instead of lying through your teeth, you could be found lying through your stomach. And is tanning addictive? All will be revealed later. And don't forget, if you have any science questions at all, then give us a bell on 08459 25 2000. And this will also give you the chance to enter our competition and win fantastic prizes, including two copies of George Pendle's book, the Encyclopedia Britannica on DVD, and a build-your-own water rocket from Super Sleuths.
That's right. George Pendle, who Catherine was referring to there, has written a book called Strange Angel, and it's about the birth of the science of rocketry in NASA. So if you're interested in that, George will be joining us shortly from America, and he's going to talk about his book Strange Angel and this guy, John Parsons, who made it all happen about 50 or 100 years ago. So if you'd like to ask any questions about rocketry, now's the time to call in. 08459 25 2000. Our quiz, science fact or science fiction, that Catherine mentioned. All you have to do is answer correctly 3 simple science facts. And if you get tonight's top score, you're walking away with those 3 fantastic prizes.
Sorting out the sparks from the quarks. The Naked Scientists. For more information, get online at nakedscientists.com.
Now, Chris, I've had an email from Brian Goodwin, and he's emailing us from South Africa, and he says, hey, I'm listening to your podcast from South Africa, and it's definitely one of my favourite ones. Thanks so much for making this available to the public. So thanks very much for Brian. It's nice to see that our audience spans the globe.
Well, we've even managed to get as far away as Maz, who's listening in the eastern region this evening. Maz says, hi, you answered my question about talking plants recently. Unfortunately, you got the idea I was female. Very sorry about that, Maz. I think that might have been Kat, actually, and she's not here this week, so I'm going to blame her. Anyway, last time I checked, I wasn't, says Maz. Anyway, congratulations on your maleness. He says, another question I have is that I have recently bought these really cool hand warmers, and when you press a button, they warm up instantly. It's a rubbery packet containing a gel and plus a metal disc, and you bend the metal disc, and then it switches on. What's the chemistry behind them? Maz, who's 17 years old. John, chemistry expert, how do these things work?
I'm pretty sure what they work with is sodium acetate. And what you've got is what's called a supersaturated solution of sodium acetate. And as this begins to crystallise, it gives off a constant heat of about 55 degrees, which is just a nice, comfortable temperature for something like a hand warmer. Now, how would you get this to work? Well, I think as you bend the metal, I think then you create surfaces which are like the crystals that could be formed from the solution. And once you trigger this, it's seeding the crystals, really. One crystal forms and another and so on, and it slowly spreads throughout the whole bulk of the hand warmer, all the time giving off this very gentle heat. Of course, eventually the heat will stop because you've crystallised the whole thing. But then you can repeat the whole process, put it in something like an oven, get it all melted again, and off you go. You can keep using it again and again and again. I think that's almost certainly what we're talking about.
I hope that answers your question, Maz. If you have a question like Maz and you'd like to put it to the Naked Scientist, we're taking anything on science, technology and medicine around the Eastern region this evening. 08459 25 2000 is our phone number, or you can email me, of course, chris@nakedscientist.com. And that's what Linda Edwards did this evening. She's in Norwich. She says, "Dear Chris, I'm really looking forward to your fascinating programme this evening. There's a question I'd like to ask. Why do we feel better after sneezing? This has puzzled me for years and I would love to know. Thanks for your attention. I look forward to learning the answer, hopefully this evening." Any ideas, Catherine? Why you do you get pleasure, John and Catherine, when you sneeze?
It's quite enjoyable, yeah.
Because when I first read this question, I thought, that's actually quite difficult. I'm not really sure what the answer is. And I thought for a bit longer. And then I thought, well, actually, a sneeze is a bit like an itch in your nose. And when you have an itch, it's extremely pleasurable to scratch it. And unless you've got incredibly long fingers, it's not easy to scratch that far up your nose, is it?
Oh, no,
and so what a sneeze actually does is uses air to do a metaphorical scratch. And what we know about itching suggests that there's a special class of nerve fibres that are very, very tiny. They're less than 1,000th of a millimetre across these nerve fibres, and they signal itchiness. They're specific for itchiness. And actually you can switch off the supply into the brain and spinal cord of itching sensations if you cause a little bit of pain. So that's why scratching an itch actually helps to relieve an itch, because when you scratch, you cause a little bit of pain and it switches off the itch signal. And the purpose of an itch, of course, is to draw your attention to an area of the body. But in the nose, you can't scratch it for obvious reasons. So by sneezing, you get that pleasant relief because you've got relief from the itchy sensation. And, of course, what it has done is to help clear out your sinuses of the gunge that's up there.
Chris, you know when you have a mosquito bite and it's itchy, what do you think the benefit that has to the mosquito?
I don't think it has any benefit. I think it has a benefit to you of alerting you that something nasty has happened to your body. I don't think the mosquito wants to make you itch. In fact, it's not the mosquito that makes you itch. It's actually what goes in, because when a mosquito bites you, the proboscis, or the mouth parts of a mosquito, are so tiny, so thin, that it's looking and fishing around under your skin for a tiny capillary, a small blood vessel to suck blood from. And once it sticks that into the blood vessel, the blood is very, very efficient at recognising a foreign surface and clotting very, very rapidly. So if the mosquito didn't inject something into the area to keep blood thin and stop it clotting, then you'd have a blood clot very, very quickly inside the mosquito's mouth, and he'd literally starve to death, because it'd be like you swallowing a tennis ball. After that, nothing's going to go into your stomach, and you'd just waste away. And unfortunately, because the mosquito's saliva is something that's not normally found in your body, the immune system says, this is nasty, I have to react against it, and it gets very itchy.
Ah, fantastic.
Can I just add something here? If you've got an itch and you actually just stroke it, it's almost as good as scratching it. Now, you're not sending quite the same signal to the brain. I know sometimes if you're not careful, you scratch something until you actually make it bleed because it's so irritating. But just stroking it will often send the desire to scratch away.
I think it relies on the same principle, though, John, that in the same way that if you bash your hand or you hit your thumb with the hammer, it hurts enormously. And the first reaction is to rub it better.
Yes.
And that's because you can control the flow of pain or unpleasant sensations into the brain and spinal cord by rubbing your hand or rubbing the area. So it does actually exert a degree of control. And I think probably the same sort of thing kicks in and exerts a degree of control.
It's not a question of releasing some molecules that will stop pain. It's nothing like that, obviously, no.
I don't believe so.
No.
It's Dr. Chris and Dr. Catherine here with you as the Naked Scientist this evening. If you'd like to ask us a question on anything science, 08459 25 2000. Of course, we are talking about blowing things up. It's the Science of November the 5th this evening with Dr. John Emsley, who's our studio guest. And joining us on the telephone later, we'll be talking to Jacqueline Ackervan too, who's an expert on pyrotechnics and how to make things go bang. If you've been to a fancy fireworks display this weekend and you'd like to know why you saw what you saw or what happened, how it all works, 08459 25 2000, or you can give us an email, chris@nakedscientist.com.
The Naked Scientists, supported by the Wellcome Trust.
Now, we hear about drug addiction, nicotine addiction, alcohol addiction, and even chocolate addiction. But addiction to the sun? Surely not. But yes, according to
Presumably not the newspaper, Catherine.
Well, I don't know, but not in this context, thanks. According to a recent survey, tanning is addictive too. Now, American scientists adapted a questionnaire normally used to diagnose people with drug and alcohol addiction and tested 150 beachgoers. And they found that over half of these people could be classified as ultraviolet tanning dependent. I think this is also known as Brits on holiday syndrome. I don't know if you've come across that.
Brits on the barbecue syndrome.
When you've been in the beaches of Mallorca. Anyway, it's thought this addiction is due to release of endorphins. These are the feel-good chemicals that are released when you're exposed to UV light, giving beach babes a sun-induced emotional high. And this might explain why, despite the risks of skin cancer, many people would rather bear all on the beach than reach for the fake tan. Do you feel better when you're on the beach sun-tanning yourself, Chris?
Yeah, that's usually, though, because I've got a beer in my hand and I'm chilling out in a very big way. Now, very quickly, I want to tell you about this because it's hilarious. Do you know what a lie detector test is?
I do.
A polygraph. How does it work? Tell us how it works.
It measures the nerve signals, and by their pattern it can tell whether or not you're lying.
Yeah, essentially, lying is, for most people at least, a stressful experience. So if you tell a lie, then usually all the hormones of stress go up in your body, and this makes your nervous system switch on its stress program. And one of the symptoms of that is that you produce a little bit of sweat, especially on the fingers, and your heart rate goes up. And those are the kind of key things that a lie detector test is looking for. But people can learn to trick a lie detector test quite well. And also, some people, just by being questioned and cross-examined, find that so stressful that they end up making themselves look like liars, even when they're not. So there's a lot of false positives that come out of it. So there's a group of scientists over in the States at the University of Texas, led by a guy called Pankaj Pazrika, and they found a way to actually make a polygraph test a lot more sensitive. And the way they've done that is actually by looking what your guts are doing, because you've all heard the saying, I've got a gut feeling, or I've got a sinking feeling in my stomach. And you know, when someone gives you a really bad bit of news, you can literally feel the bottom fall out of your world, quite literally, can't you? Your stomach feels very, very strange. And the reason for that is that when your body's preparing to run away or go into a stressful situation, the last thing you want to be doing is wasting energy digesting your dinner. So your body shuts off your gut and tells it, stop doing the digestion bit, put all the blood flow that would be doing that into muscles so I can run away or fight or whatever. And so, if you monitor what the stomach is doing electrically, whilst asking people to tell lies, you find a very interesting thing. You find the nerve activity in the stomach goes right down to zero in a large proportion of people. So what these guys are suggesting at the University of Texas is that not only should you be strapping a little electrode on people's fingers to see if they're sweating a bit and their heart rate's gone up, but you should also be monitoring their stomach activity. And this is actually referred to as an egg or an electrogastrogram. So it's quite ironic that the way to find out whether someone is telling a porky is to give them an egg.
Very good.
It's The Naked Scientist, Dr. Chris and Dr. Catherine, with you until 7. We're tackling anything to do with science, technology and medicine. Email me, chris@nakedscientist.com. Right now, it's time for Kitchen Science. We want you to experiment at home alongside us here in the studio and with Derek and Dave, who are in Ecton Brook in Northamptonshire. They've got Sam and Sebastian with them in the kitchen this week. They're going to be making a homemade fire extinguisher. You need some acid, vinegar or citric acid from fruit, and you need some baking soda. We want you to try this at home, and the first person through on the telephone with the correct observation will win themselves a prize. Right, Derek, what have you got for us this week?
Yes, hello, Chris. We are here in Ecton Brook in Northampton, and we are all literally bubbling with enthusiasm, ready to do this week's experiment, which, of course, you can do at home too. So just listen carefully, and we'll tell you all you need to know. And here with me, of course, is my partner in scientific crime, Dave. Dave, what have we got lined up today?
Well, this evening, Derek, we're going to be making a homemade fire extinguisher.
A homemade fire extinguisher, fantastic. And also we have some wonderful helpers here. Guys, tell us your names and ages, please.
Hi, I'm Sam, and I'm 9 years old.
Fantastic. And yourself?
Sebastian, and I'm 9 years old as well.
You're 9 as well. Excellent. And you guys do science at school. Sam, what's your favourite thing about science?
Well, I like doing experiments.
Great stuff. And yourself, Sebastian?
I don't like experiments, so I'm putting my hands up, but I hope I'll have good fun.
And I think we're going to convert you today, because this experiment's going to be very, very cool. And so, you at home as well, you can do this experiment. It's very, very easy, and it is great, I assure you. Basically, all you need is a pint glass, you need some bicarbonate of soda, some vinegar, some, a sufficient quantity, like a cupful or something like that, and a candle and something to light it with. And also an adult around would be great to help you kind of light the candle and so on, because that's always very safe. And also a teaspoon to measure things out. And I think that's about it. So, Dave, what do we do with all these things?
OK, Sam, could you take 3 or 4 teaspoons of bicarbonate of soda and put it in the pint glass?
OK, now, Sam's got the pot of bicarb here.
There's 1, 2. There's 3.
That'd be great.
Okay, so we've got 3 teaspoonfuls there in the pint glass. Thanks for that, Sam. Okay, and what next, Dave?
Now, the next thing you should do is pour about a centimetre and a half of vinegar over the top of them. It'll also work with lemon juice or anything like that.
So Sebastian's doing this now. And what's happening, Sebastian?
Oh, it's going fizzy.
Okay,
A
then.
bit more in, I think.
Right, we're going to put a bit more in because we want lots of bubbles here, guys, okay?
Wicked. It's going to overflow.
Oh, and it's just overflowed a little, but we've got lots of bubbles there, so that's looking very healthy, isn't it, Dave?
That's exactly what we want to see, that's right.
Okay, so we've put some vinegar, glugging some vinegar there onto the bicarbonate of soda in the pint glass, lots and lots of bubbles, and then what next?
Now, what you're going to do is light the candle, and then imagine that the glass was full of water, and imagine you're pouring the water which isn't there over the top of the candle, and see what happens.
Okay, so now the bubbles have basically gone down, we're going to imagine that the glass is full of water, and we're going to pour it over a lit candle, basically. So that's the idea, but we're not actually pouring any liquid over, are we?
That's exactly right, yeah.
Okay, so guys, what do you think is going to happen? We're going to pour this kind of empty space over a candle. What do you think is going to happen, Sam?
The candle might melt.
The candle might melt. And what about you, Sebastian?
I'll just have to wait and see.
Oh, okay, well, we're not going to tell you just yet what happens because we want you to do it at home. It's very easy, of course, and here's a little recap for you. All you need to do is place a few teaspoonfuls of bicarbonate of soda in a pint glass and then half a cup of vinegar, something like that on top of it. It's going to fizz a lot, so wait for all that fizzing to go down, all the bubbles to go down, and then, pretending the glass is actually full, you've got to pour it over a lit candle, okay? So have an adult there for that, that would be very good. Don't actually pour any liquid on it, of course, you just need to kind of pour it as if the glass was full. So what happens? We want you to tell us. It's not difficult at all, and what's more, the first person to contact us with the right answer will get a prize. So, please call this number if you'd like to try and get that prize with your result. It's 08459 25 2000, or you can email at chris@thenakedscientist.com. And if you haven't got the ingredients, why not go and ask a neighbour? You'll both enjoy it, we assure you. And towards the end of the show, we'll be back with Dave's explanation and some more cool stuff you can do at home. So, until then, it's back to you in the studio, Chris.
Thanks very much, Derek. It is, of course, The Naked Scientist with me, Dr. Chris Smith, Dr. Catherine Hawkins, here with you until 7. We're tackling anything to do with science, technology and medicine, and we're joined in the studio tonight by Dr. John Emsley, who's a professional chemist and a prize-winning author all about chemistry. We'll be asking him about the science of fireworks and how things go bang and how you get those amazing effects at fireworks displays. If you'd like to ask John a question, you can talk to him yourself, and if you'd like to get through to us on email, chris@nakedscientist is the way to do it. Rebecca's in Hemel Hempstead. Hello, Rebecca.
Hello.
Good evening. How are you?
I'm okay, thank you.
Right. Hit us with your question.
How's a rainbow made in the sky?
Wow, that's a lovely question. What do you think the key ingredients of a rainbow are? If you have a look in the sky, what's happening when you see one?
You can see colours.
Yeah, but look in the sky, as well as a rainbow, what else is usually going on when there's a rainbow in the sky?
Rain.
Rain, excellent, that's one ingredient. What's the other thing you need?
Sun.
Exactly, you don't see them at night, do you?
No.
Right, well, the reason you get a rainbow is that sunlight shines into a raindrop. And raindrops are only very tiny, of course, and the light waves go into the raindrop, and the back of the inside of the raindrop's very much like a mirror. And you know what a mirror does, of course, it reflects things, doesn't it?
Yeah.
So the light bounces off the back inside surface of the raindrop and comes back out of the front. Have you ever seen a prism?
What?
A prism.
No.
Well, what that does is it splits light up into all of the different types of light that make up white light, because as you probably know, white light is actually a mixture of lots of different colours. And so when the light comes back out of the raindrop, out of the front surface of the raindrop, it splits the light up into all of the different colours that make up white light. And so you get the reds and the yellows, and then it goes to green, and eventually you get to blue lights. And that's where you get that nice strip of colours outside in the sky, making a rainbow.
Mhm.
Does that make sense?
Yeah.
Now, have you seen sometimes not just one rainbow, but two?
No.
Have you never seen it when you get a rainbow and then there's another one which is a bit dimmer, but they're still there outside the first one?
I think so.
Yeah. Can you guess what might be happening there?
Is there a lot of rain?
Well, yeah, you do need quite a bit of rain, but you need quite a lot of sun to see it too. But what's happening then is that instead of the light coming straight out of the raindrop, some of the light bounces back inside the raindrop again and does the journey again for a second time, and then it comes out. And so you get 2 rainbows, one outside the other. Clever, isn't it?
Yeah.
Do you want to have a go at the quiz?
Yes, please.
Okie dokie. Of course, up for grabs tonight is a DVD copy of Encyclopaedia Britannica, or we've got some books to give away. We've got one of George Pendle's books, which is all about how rocketry first was invented. Or there's a copy of John's book. John's here in the studio, and he's got a book called Elements of Murder, which is all about how to kill people. You might not want a copy of that. Or from sciencesleuth.co.uk, we have got a build-your-own water rocket at home set. So which of those do you think you might like, Rebecca?
Build your water rocket at home set.
OK, let's see if we can win you one, OK? Here we go. First question. The lifespan of a bed bug, these are creepy crawlies that live in your bed. The lifespan of one of those is about 6 months. Do you think that's fact or fiction?
Fact.
Well done. Bedbugs can survive in your bed, feasting on you each night for about 6 months.
Now, this is a hard one. Are you ready?
Yep.
Metal boats pass electricity into the water to stop themselves going rusty. Do you think that's fact or fiction?
Fact.
Wow, well done again. The metal parts of boats are protected by a structure known as a sacrificial anode. This is a piece of metal, often zinc or magnesium, which is more reactive than the metal components of the boat, usually iron. So instead of the iron rusting, the sacrificial anode dissolves instead, protecting the boat.
You're doing brilliantly. 2 out of 3. Are you ready?
Yep.
Superglue gets stickier if you add some water to it. Is that fact or fiction?
Fiction.
Oh, well, that was still not a bad run. Superglue contains a substance called cyanoacrylate.
Cyanoacrylate, even.
Sorry, Chris. Whenever it comes into contact with traces of water, the cyanoacrylate molecules form a dense meshwork of crosslinks gluing themselves together. And that's why superglue sticks to skin so well, because fingers are covered in a thin layer of sweat.
Well done, Rebecca. 2 out of 3, so you're in the lead at the moment, all right? So there's a water rocket with your name on it if no one beats you.
Okay.
All right, thanks for your call. See you later.
Okay,
Bye.
bye.
It's the Naked Scientist, Dr. Chris and Dr. Catherine, here live on BBC Local Radio right across the eastern counties. Tonight we're talking about the science of fireworks, and also don't forget Derek and Dave are in the kitchen with Sam and Sebastian in Ecton Brook in Northamptonshire. They're making a homemade fire extinguisher. Very simple. Get some baking powder, get some vinegar or some citric acid, fruit juice acid, and add the two together. See what happens, then ring us up and tell us. If you're the first through on the phone with the correct observation, 08459 25 2000, and you can explain the science of what's going on, then you could win yourself a fantastic prize. We have an Encyclopaedia Britannica DVD to give away. We have a copy of George Pendle's book. We have a copy of John's book, which is all about how to kill people. Well, it is, John, chemically speaking. And how people did kill people very efficiently in the past.
Yes.
And we also have a rocket. You can build your own homemade water rocket from sciencesleuth.co.uk. James is in Ipswich. Good evening, James.
Good evening.
How are you?
Yeah, fine, thanks. How are you?
Very well, thank you. And your question is what exactly?
How is the best way to burn fat from the abdominal area? In other words, a beer belly. And why does it collect there?
Now this really is a really Nobel Prize-winning sort of level of question, and if you could answer that, and if I could answer that, then I'd be going on my way to Scandinavia to get a Nobel Prize. The easy answer is, have you noticed that men tend to put weight on round their middle, a beer belly, and women tend to put it on round their bum?
Yes.
So there has to be a genetic component to this. And the old saying goes, that women put it on around their hips and bum because they're going to breastfeed. That's their store for pregnancy.
Yeah.
Men put it on around their middle, and they have a very different distribution of fat. It tends to be deposited around the organs in the abdominal cavity rather than just under the skin. Women tend to have much better insulation under the skin than men. So, yes, there's definitely a genetic component to this. We don't know precisely why and how the body decides that site is going to be the lucky recipient of the 5 pints of lager in terms of calories that you've had each night of the week. We don't know that. But what we do know is that you can lose that weight just as easily as you can lose weight from anywhere else if you resort to the right kind of exercise regimen.
Right.
And the thing is that the laws of physics aren't really being rewritten in the stomachs of people who are a touch overweight. Energy in equals energy out. Plus or minus any weight gain. So in other words, if you're not burning off energy you're taking into your body, then the energy has to go somewhere.
Yes,
and the body
indeed.
says the most efficient way to store energy is to turn it into some fat, and I store that under the skin, or if I'm a man, then you get a little bit of a beer belly. Or a bigger beer belly, depending on how dedicated your cause is. The way to burn it off is you've literally got to increase your energy expenditure, and that means doing more exercise, unfortunately. And that means you have to bear in mind how much energy you burn off doing things. Walking, for example, burns 300 calories per hour. Sitting on the sofa burns 60 calories per hour. So watching TV burns about 60 calories an hour. If it's a really exciting TV programme, perhaps 70. If it's a version of Countdown, perhaps 75, because you have to use your brain a bit too. But most TV programmes, especially on Channel 4, probably not so good.
Right.
Probably negative calorie energy, I should think. But so doing some exercise is a great way to actually increase your amount of energy you burn off. And at the same time, you can speed up the process by taking slightly less energy into your body. And you have to remember that the key thing, the thing that packs the massive energy punch, is fat. And the more fat you have in your body, in your diet, then that's very energy dense. There's a lot of calories packed into that, and fat makes people fat very quickly. So try and cut down on the fats a bit. It's not true to say that cutting out all the sugar and the carbohydrates is a good thing to do if you're trying to lose weight. It's not true. Carbohydrates are not as energy dense as fat, and they fill you up very efficiently, and they release energy gently into the body. John?
And also, alcohol's quite a high level of fat. Ordinary fat is 9 calories per gram. Alcohol is 7.
Good Lord.
Yes, I mean, it's easy to have, a couple of gin and tonics and think, oh, well, that's not mostly because I'm using Slimline tonic or something like that.
Yeah.
But it's the alcohol that's actually going to deliver the calories.
The calories.
Yeah.
The reason I phoned and asked this question is because I've been to my doctor's last week, and she said that I need to lose weight, and my cholesterol level is high, higher than it should be for my age. And we sat listening to the radio, and I thought, well, I'm going to phone in and ask.
Well, it's true, James. She's right. If you have, if you do carry a little bit of extra weight, it does put your cholesterol level up.
Yeah.
Okay. So if you drop your weight down, often you can get your cholesterol down to almost normal, or to within normal limits, without even having to take drugs, and that's a good thing if you can manage that. Do you want to have a quick go at the quiz?
Oh, go on then.
You can win yourself an Encyclopedia Britannica DVD that's worth nearly £100.
Right.
Or you can go for that water rocket. Fires burn better under low gravity conditions, such as an orbiting space rocket. Fact or fiction?
Fact.
Oh, I'm afraid that's not right. Fires won't burn properly without gravity. On Earth, heat rises, carrying hot waste gases away from a fire and allowing fresh oxygen into the base to keep things burning. But in space, under microgravity conditions, there's no up or down, so all of the waste gases from a fire accumulate around the thing that's burning, choking its air supply and putting it out.
I should know that, shouldn't I?
Is it quite ingenious? Because have you been listening to Kitchen Science tonight, James? Are you going to have a go? Because Derek and Dave are eager to see if anyone can make this homemade fire extinguisher.
Well, we did the vinegar with the bicarbonate of soda, and it did put the candle out.
Did it?
Yeah.
Ah, right. Okay. Have you told our guys here that?
Well, no, I haven't. No.
Okay. Well, we'll have to wait. We'll have to put you in the hat, maybe. Next question. Earth's moon is an old asteroid that was caught by Earth's gravity shortly after the Earth formed, and it's been around our planet ever since. Fact or fiction?
Oh, crumbs.
You've got to get this one right, really, to stay in the race.
No, that's fiction.
Hey.
Correct. The moon was caused by a planetary pile-up involving the Earth and a second Mars-sized planet notionally named Theia, which occurred not long after the Earth first formed. The resulting collision threw huge amounts of Earth's crust into orbit, where it slowly aggregated to form the moon.
Well done, James. You've got to get the next one right, okay?
Okay.
Sharks are cold-blooded. They're all cold-blooded. Sharks are all cold-blooded. Fact or fiction?
No, that's fiction, because they're warm-blooded, they're mammals, aren't
right and wrong. But stop with the that's fiction. That'll do fine.
You've come good under pressure. Well done. It's a fallacy that all fish are cold-blooded. Some sharks, including salmon sharks, are warm-blooded and have a core body temperature similar to our own. They produce this heat by continuously swimming, burning off energy in so-called red muscle deep inside their bodies.
Right.
2 out of 3, James, puts you in equal first place at the moment. Or 1 out of 3. Sorry, you're in second place. All right.
I don't think I'm as young as your other contestants.
Okay, you're going to be heading for the books, I would think.
I ought to know more, don't I?
Oh, well, read John's book and you will. All right, then.
Okay.
Or the Encyclopedia Britannica.
Thanks a lot, James.
Thank you.
See you later.
Cheers.
Dr. Chris and Dr. Catherine here as the Naked Scientists on BBC Local Radio right around the eastern counties this evening. If you'd like to ask us a question, 08459 25 2000, or you can send me an email, chris@nakedscientist.com. We're talking science of November the 5th, explosives, fireworks. Jacqueline Ackervan's going to be joining us shortly. She's an expert on how things blow up. If you've got a question for her, call me now, 08459 25 2000.
Fancy listening to The Naked Scientists in your bed, on your way to work, or even at work? Why not subscribe to our podcast? For more information, visit nakedscientist.com/podcast.
Now, would you be mad enough to send yourself into the heart of a hurricane? Well, Mark Schroep did precisely that to find out what was going on in the eye of Hurricane Rita when it was laying waste to half of America. But why did he do that? What was it all about? Mark Schroep joins us from Florida to tell us why he got into an aeroplane and flew into the eye of Hurricane Rita.
I wanted to learn about a program called RAINX, which is looking at why it is that hurricanes can dramatically shift from a Category 3 to a much more devastating Category 5 in the matter of really in the space of a few hours, which happened this year with a couple of storms. And so I tagged along on a NOAA research flight into Hurricane Rita.
It sounds like quite a crazy thing to do, to get on an aeroplane and fly straight into the heart of a hurricane, but this is actually standard practice, isn't it?
It is, and it's been going on since the 70s, so on the one side you could feel kind of safe that they know what they're doing and have been doing it for a long time, or you could look at it as the time is coming and they've been at it so long, it's time for something to happen.
So you took off and you were heading into the heart of Hurricane Rita.
We left from Tampa, which is where the planes are based, and started seeing the storm within 30 minutes of leaving the coast of Florida, because the storm was so massive it just about filled the whole Gulf of Mexico. It's kind of funny, really. They have a fasten seatbelt sign like you would have on a commercial airline, but it comes on and off, and so you might see it and run to your seat, and it might be on for a minute and a half, and then you're able to walk around again.
You were experiencing wind speeds, one would assume, of 110 miles an hour or so, but what was it actually like flying through the eye and then into the eye wall where the winds are most intense?
One side of the hurricane wasn't as bad as the other, so it would be rough on one side, and on the other side you would get really, really beat up, and going through the eye wall, it was a complete whiteout. You couldn't really see anything but cloud, and of course feel the turbulence that you were flying through. In the eye, it calmed down and it got a little sunnier, but in the case of the day that I was flying, there was a good bit of cloud cover, so there were still clouds even in the eye.
And what was your most vivid memory of the experience?
Probably taking the hits going through the eye wall for sure. There was one time when my arm flew up above my head from the impact. I think that was one of the times when there was probably a 1.5 to 2 G force there. One of the other planes that was doing the same thing actually got hit once with a 3.5 G impact.
So how are the measurements collected? Have you got a group of scientists on board the plane with you and they're all looking out of the window making measurements, or is it all down to clever machinery?
They have Doppler radar is one of the big tools. They have these instruments called dropsondes that they drop out of the bottom of the plane. So we had probably 17 or 18 people, including the flight crew, working pretty frantically the entire 9-hour flight. So you've got a bunch of different stations with computers, and some people are looking at at radar data. Some people are looking at the data coming back from the dropsondes and that kind of thing.
Have there been any data produced so far that have led to a better understanding, or is that why 3 planes are now up this year rather than the usual 1?
Well, the reason for the 3 planes is that they have this theory that what happens is you have rain bands that in the classic hurricane shape are feeding into the eye, and they think that those rain bands are actually sort of transferring energy into the eye, and then you go through different places in the cycle where the bands on the outside of the eye make their own, they call it a secondary eye wall, and then kind of starve the eye of power, and things weaken, and then that secondary eye wall becomes the eye, and it starts gathering strength. So the reason for the 3 planes was so that they could have people simultaneously at all these different points in these important structures. They have somebody flying into the eye, somebody around the outside of a rain band, and somebody on the inside of a rain band.
Mark Schroep from Florida in the US describing his flight, not to somewhere exotic, in fact quite the contrary, straight into the heart of Hurricane Rita.
Stripping down science.
Okay, let's do it.
The Naked Scientists.
Dr. Chris and Dr. Catherine with you until 7 this evening as the Naked Scientists, taking your science questions. We're having a special look at the science of explosions this evening because it has, of course, been bonfire night. And joining us now from Cranfield University, Jacqueline Ackervan. Hello, Jacqueline.
Good evening.
Pyrotechnics expert. You like blowing things up. What a fantastic job to have for a living.
It's fascinating. It means I can practice my chemistry. Fireworks and explosives is just pure chemistry.
How did you get into blowing things up?
Well, when I became a lecturer at Cranfield University, I was trained in polymer chemistry, and my professor at the time, his expertise was in explosives, and I didn't actually realise, but polymers and explosives do actually come together quite nicely in polymer bonded explosives. So I sort of got involved in research in putting explosive compositions in a polymeric network.
So for the layperson, a polymeric network means what?
It means that polymers are like plastics, and what you do, you take an explosive crystals and you embed them in this sort of plastic network which holds all the explosives together.
What, in just the right way so that they go off really efficiently?
It's not quite in the right way. It's a binder. It's like when you're making bread dough, how eggs bind flour together, and when it sets, you form a bread or a cake when it rises in the oven. It's exactly the same. Polymers start off wet, and when you put them in an oven and when they sort of react, they form a solid lump embedding all the explosive crystals.
Now let's talk about fireworks for a bit.
Yeah.
How do you actually make fireworks so that they produce these fantastic shapes? In other words, you see a starburst and all of the bits go out in just the right direction with this beautiful even spacing in the formation, and then they do secondary things like the blue ones turn into red ones and then turn into green ones. How's that achieved?
Okay. First of all, if you start with the various shapes, these are called mortar bombs. Where it's like a very large football, and so it's a huge sphere, and inside that sphere are these small fireworks like fountains, and the design you want to see when it's up into the sky, exactly the same design you put on a much smaller scale. For instance, if you want a heart, you arrange all these small little fireworks into a heart shape, so when the mortar's sent up into the sky, when it burst apart, the heart actually bursts apart, and you see an enlarged form of a heart, and the small fireworks are burning in a heart shape. Now, to get the change in colour is again quite a simple way of doing it. You have like pellets, and one pellet will contain a composition that burns red, and then you add a compound called strontium to that, and then you attach that to another pellet which might burn with green. And when it's in, again, a mortar bomb, when it's burst in the sky, the red bit burns first, and you see the red burning, and as it burns through that pellet, it then comes into a green composition, and that burns second.
Oh, I get it.
And you see the change in colour.
John?
Now, can I ask a question here? Because I was once told that the way to judge a firework display was the quality of the blues that can be produced in the sky. And I know that, for example, purples are very rare indeed. Now, why is that, Jacqueline?
Well, John, blue is a really hard colour to produce. First of all, to get blue, you need to add a composition which contains copper.
Yes.
And the blue that you actually are seeing is copper chloride. Well, we have to add some chlorine to it because chlorine seems to intensify the flame colour. And copper chloride is a very unstable species. And if the flame temperature is too high, copper chloride breaks apart and you don't see blue. So we have to somehow cool the flame temperature down, so copper chloride remained intact for some time, so we actually see that blue colour.
And why do you never see purple?
Well, purple is again quite a difficult colour to produce. To get purple, you have to mix two compositions together.
Yeah.
You can mix, for instance, red with yellow to get orange. But blue is such an unstable species of copper chloride, it's quite hard to mix it with other compositions because the flame temperature will be raised again and you don't get your blue colour.
Can I ask, when you see fireworks and they have lots of different noises, some of them are whistling, some of them are crackling, what's the chemical basis behind making those kind of noises?
Okay, for the crackle one, the crackle noise is actually titanium metal flakes burning. Now, titanium has an oxide layer, but the actual oxide layer is very, very thick compared to the oxide layer around magnesium or aluminium.
And that stops the air getting at it to make it burn, is that what you're saying?
It doesn't actually stop the air. What it is, all metals will have an oxide layer. So what happens is when you actually got titanium inside a flame, the metal actually melts and the oxide layer cracks open. So the metal doesn't actually burn, it simply melts. When the oxide layer cracks open, then you start getting your white sparks, which actually is your titanium metal burning. But the breaking open of the thick oxide layer is the actual crackle sound of the titanium metal.
But what about those sort of shrieky noises? Do they actually embed something in the projectile so that it has some kind of whistle attached to it or something?
No. Now the whistler, what happens with the whistler rocket is that you have your composition, your rocket whistler composition, and it's in a cardboard tube which is only about filled a quarter at the top end of the cardboard tube, and the rest of the end is open. And when you ignite your whistler from the open-ended cardboard tube, as it burns on the surface, you get these small explosions occurring, which are these crystals, actually tiny explosions. And those small explosions cause the cardboard tube to vibrate. And as it's vibrating, just like a tuning fork, you actually get a sound, a resonant sound occurring. And what happens with the whistler, once you've got this resonance happening, you sort of get like this standing wave inside this cardboard tube. As that composition burns away, the actual standing wave, as we call it, gets longer, and the frequency of that whistler goes down.
Oh, that's why the sound changes. I get it.
So what do you think the future of fireworks is? I mean, where do you think we're going to see them going next, at the real cutting edge?
Okay, there are some new there are new fireworks being developed, but the most important thing for the future of fireworks will be the safety aspect, particularly in the manufacturing process, because all the fireworks are actually made by hand, and all the fireworks now for commercial use are being imported from China. And so when they make them in China, there is human contact, and when an accident happens, people die. So it's an automation of the process. That's the first thing. And second one will be safety of the users, to make sure that no accidents or fireworks explode when you ignite them.
Sure.
And thirdly, surely the biggest firework in the world.
Jacqueline, thanks. We're going to have to leave it there because we're out of time, but thank you ever so much for joining us this evening.
It's my pleasure. Okay,
thank you.
Bye-bye.
Jacqueline Ackervan, who's a pyrotechnics expert from Cranfield University, is Dr. Chris and Dr. Catherine on The Naked Scientist, right around the Eastern Counties, live on BBC Local Radio this evening for your listening pleasure. If you have any science question to do with anything to do with Bonfire Night or anything to do with just science in general, 08459 25 2000. Don't forget that Derek and Dave are with Sam and Sebastian in Ecton Brook in Northamptonshire, and they've made a homemade fire extinguisher with some acid and some sodium bicarbonate, and they want you to try it at home, obviously with help and supervision. It is dangerous because it can involve a lit candle, so always get some help from an adult if you're young. But have a go, and if you can explain the science of what's going on and what happens when you pour that gas out, ring us now, 08459 25 2000. In the studio with us is Dr. John Emsley, who's a science writer and a chemist by trade, and he's going to tell us a bit more about pyrotechnics in just a second. But first, let's get down to the nuts and bolts of where rocketry came from in the first place. George Pendle's in New York. Hello, George.
Hi there, Chris.
You've written this book, Strange Angels. It traces the history of rocketry.
Yeah.
But where did rocketry actually come from in the first place?
Well, it's very interesting. We see rocket scientists today, or if we think of rocket scientists today, we think of men in white lab coats, pressing buttons in mission control with brains the size of small planets resting on their shoulders.
Or even large planets.
Yeah, or even large planets, indeed. But this hasn't always been the case. I mean, up until the middle of the 20th century, rocket scientists, or at least those who dabbled in rockets, were lunatics or were seen as lunatics and crazy men and dealing in a field that was impossibly dangerous. And more often than not, most of these early practitioners of rocketry blew themselves up in the process.
So when did it become a real serious science then, George?
Well, it really became a serious science in around the 1930s or 1920s. Really, to trace it back, we have to go back 1,000 years, which is the history of rocketry. I mean, rocketry is an old science, even though it hasn't been treated as one. If we go back to ancient China, some of the earliest writings about rockets refer to them being used as weapons, and the ancient Chinese texts refer to fire arrows being used against Mongol hordes, being these sharpened bamboo tubes filled with a combustible mixture of charcoal, saltpeter, and sulfur. And these could be fired 1,000 feet. And cause great terror amongst the army ranks. But this is 1,000 years ago, and for 1,000 years after that, really there was no major breakthrough in rocketry.
So when did things all begin to change?
Well, in about the 1930s, rocketry was probably at its lowest ebb. Rockets weren't being, taught at rocketry wasn't being taught at any universities. It wasn't being funded by really any governments. And in fact, the only place it existed was in the science fiction pages of science fiction magazines or stories. And it really began to change when all these young enthusiasts, these guys who were 20 years old in the 1930s, were fueled by these stories of Jules Verne and H.G. Wells and really wanted to make it a reality. And they wanted to put what was in print into reality and try and get into space with a rocket.
And this is where Jack Parsons, who you've written this whole book about, comes in, I guess.
That's correct. He was a self-trained young guy, fanatical about science fiction. He lived in Los Angeles in the United States in the 1930s. And really, he just went to the California Institute of Technology, which was one of the great scientific institutions at the time, and said, hey, I want to build rockets. And nobody took him seriously apart from, one rather wise man named Theodore von Karman who thought there might be something in this rocketry business which everybody else had derided.
And did he actually succeed?
Well, he did. If you look at Jack Parsons, he's at the very first step on the road to man walking on the moon. He invented, he got the U.S. government interested in rocketry, and if you take a look at a similar young man who was in Germany at the time named Werner von Braun, also a fanatical science fiction man.
The guy who came up with a V2?
Yes, indeed. He basically made rockets, a terrifying weapon, but also, allowed it to become a reality.
Well, thank you, George. We're going to have to move on now because we are a little bit short for time. But thank you for joining us and telling us about the background to rocketry. And we have 2 copies of your book, which people can win this evening. In fact, we've got 2 contenders already, you'll be pleased to hear.
Oh, fantastic.
It's Strange Angel, and it's been out for a couple of months now, isn't it?
Yeah, that's right. Since July. I hope whoever wins it enjoys it.
Thanks, George, for joining us.
Okay, my pleasure.
George Pendle from New York, who's written the book Strange Angel, and it's all about the history of rocketry, talking there about his book. If you'd like to have a go at winning a copy, we have a couple of minutes, might be able to squeeze you in. 08459 25 2000 is our number. It's Dr. Chris and Dr. Catherine here on The Naked Scientists until 7. Right, let's have a quick chat to Catherine. Hello, Catherine.
Hello.
Right, we have to be very quick, so what's your question?
When you snap a glow stick, what makes it glow?
John, this is a photoluminescent reaction, so these things you see people walking around with at the...
Yes, it's luminol that you're activating. It's a chemical that that things like glowworms produce, and you can carry it around, but you need to activate it, and the thing you need to activate it with is generally hydrogen peroxide. And when you break this thing, of course, you're then mixing chemicals together, and it begins a reaction. It won't last forever, of course. It's got a limited lifespan, but you can do just what fireflies have learnt to do naturally.
There you go, Catherine. It's a chemical reaction in front of your eyes.
Yeah.
Do you want to have a go at the quiz?
Yes, please.
OK, we're going to have to be very quick with this, all right?
Yeah.
In a hurricane, the winds are strongest in the eye of a storm. Is that fact or fiction?
Fact.
Bad luck. I'm afraid that's wrong. But in the eye of a hurricane, which ranges from 8 to 200 kilometres across and lies at the centre of the storm, it's calm and still, fooling some people that the storm has passed. In fact, the other half is yet to come. The faster speeds tend to be recorded at the edges of the eye.
Catherine, got to get the next one right, OK? Here we go. A bee flaps its wings about 500 million times in its lifetime. Do you think that's fact or fiction?
Fact.
Well done you. During their short lifespan, the average bee clocks up at least 500 million beats of its wings.
That's quite a lot, isn't it? Next question, Catherine. Humans move their backbones an estimated 1 million times during their lifetime. Do you think that's fact or fiction?
Fact.
Oh, bad luck. The average human moves their backbone at least 100 million times during their lifetime, if you can believe that.
You got 1 out of 3.
Okay.
Not bad. Second place at the moment, okay?
Yeah.
All right, thanks for calling in, Catherine.
Bye.
See you later. The Naked Scientists, Dr. Catherine and Dr. Chris, we're here with you until 7, and very shortly we're going to be finding out whether or not anyone has got the answer correct to Derek and Dave's kitchen chemistry for this week, which is all about making your own homemade fire extinguisher. And we're going to be talking to Michael, who's in Norfolk. Michael, you've been doing this. Hello.
Hello, how you doing?
I'm all right. What did you think?
We found that the flame went out.
Okay.
I think we made carbon dioxide, and carbon dioxide is heavier than air.
Yep.
Dispel the flame.
Very good. I like it. I like the logic. Shall we go back to that kitchen and see if you're right?
Yes, Annie.
All right, then. Hang on the line there, and we'll see if we can get back to Derek and Dave and see what they're up to. Of course, if you would like to have a go at our competition, there'll be a couple of minutes before the top of the hour. 08459 25 2000. We have to give away a build-your-own water rocket from sciencesleuth.co.uk. We also have an Encyclopaedia Britannica on DVD. We have a copy of George Pendle's book, and you heard George talking there, and we also have a copy of John's book. John Emsley's here with us in the studio. His book, Elements of Murder, which is an excellent way, if you're thinking of bumping someone off, to work out how to do it. Right, let's get back to that kitchen and see what Derek and Dave are up to with Sam and Sebastian in Ecton Brook in Northamptonshire. Derek.
Hello, Chris. Yes, we are still here in Ecton Brook in Northampton with the completion of the experiment that we told you about earlier, really ready to happen right now. And Dave's ready to light a candle, and Sam and Sebastian are here too, ready to actually do the experiment and tell us what happens. So, guys, you ready? You want to know what's going to happen?
Yeah, definitely. Yeah.
Good stuff. OK, Dave, so what have we got to do then? We've got to basically do this all in one go, haven't we? We've got some bicarbonate of soda in the glass. What next?
OK, so now, Sebastian, if you could pour the vinegar on top of the bicarbonate of soda again.
So this is what Sebastian did earlier, but we're going to do it all in one go now, so he's doing it again. There it goes, it's fizzing up. That looks good, and the bubbles are dying down.
OK, so I'm now going to light the candle. Now, Sam, could you pick up the glass and now pretend it was full of water? As if it was full of water, can you pour it onto the candle?
Oh, what happened?
It disappeared. The front of the candle was diminished.
How's the flame out? What do you think?
I thought because the vinegar was very cold and sparkly, it made the fire go out.
OK, but did we actually pour any liquid on that flame?
No.
But I guess there was just something in there, wasn't there? I mean, why do you think the flame went out, Sam?
There might be little tiny bubbles that fly out, and they might hit with the candles.
Well, we've got Dave here, who is the man with the explanations all the time, so he's going to be telling you what is actually going on there. So Dave, what's happening?
Well, first off, why does it fizz? Well, locked up inside the bicarbonate of soda, there's a gas. Have you ever heard of carbon dioxide?
Yeah.
Yeah, what's carbon dioxide?
It's the special air.
It's a kind of air, it's a kind of gas. It's a kind of gas which you breathe out. Now, locked up really tight in the bicarbonate of soda, there's this carbon dioxide, OK? When you add vinegar, which is a kind of acid, and so is lemon juice and things like that, if you add that to bicarbonate of soda, it fizzes lots. I don't know if have you ever eaten sherbet, which fizzes in your mouth? OK, but that's got bicarbonate of soda in it, and the fizz is exactly the same as this. Now, carbon dioxide is heavier than air, so instead of just like floating out of the glass, it will just sit at the bottom of the glass, a bit like water in the glass. But it's invisible, so you can't see it. Now, when things burn, OK, they take in fuel, they've got fuel, and they take in something called oxygen, which is the gas which you breathe in.
And you guys have heard of oxygen as well, have you?
Yeah.
And they turn it into carbon dioxide and maybe some water as well. So if you pour carbon dioxide onto a flame, it's like pouring its waste product onto the flame. So it's a bit like you eating wee.
Can you guys imagine living on wee? That's your waste product.
Ugh.
I agree, absolutely. So really then, the flame needs oxygen. It can't live on carbon dioxide, but you pour carbon dioxide on it, just can't stay up, can it?
Yeah, it will just go out.
OK, fantastic. So we've just made a homemade fire extinguisher then, have we?
Yeah, some of the fire extinguishers are basically a cylinder of carbon dioxide which is compressed down really hard. They tend to be the ones with a little horn on the end. And if you press the lever, it just squirts out carbon dioxide all over the flames that will put them out.
OK, and so what other kinds of fire extinguisher do we have?
Well, there's also bog-standard water ones. It's a bit like throwing a cup of water over a candle. It just makes the fire cold and it puts them out. You also get powder fire extinguishers, which are actually made out of bicarbonate of soda as well.
Oh, so we can make another fire extinguisher here, guys.
So, yeah, we can make another one. So if I light the candle again... Oops. OK. Sam, could you take a little pinch of bicarbonate of soda? Yeah, that's right. Now put it onto the flame.
Just sprinkle it from the top. Hey, what happened?
The spark disappeared.
Yeah, so the flame disappeared.
Yeah.
So we've made another fire extinguisher, really.
Because another way to get the carbon dioxide out of bicarbonate of soda is heating it up. So if you throw bicarbonate of soda onto a flame, it will release all that carbon dioxide and it'll put the flame out.
Fantastic. So which fire extinguisher is the best?
Well, powder fire extinguishers will work on absolutely anything, but they make a horrible mess because you cover the place in white powder.
What about the water one? How good is that?
Well, they will only work on like burning wood or burning paper, but it can fly miles because water's quite heavy, whereas a carbon dioxide fire extinguisher just kind of will only go a few feet.
OK, so guys, you've seen some different types of fire extinguishers here. What did you think of the experiment, Sam, firstly?
It was clever.
Excellent. And Sebastian, what about you?
I think I like experimenting now because it's so fun.
So you're a convert, you like science now?
Yeah.
Great stuff. Well, thank you very much for being our helpers today. You've been absolutely fantastic. And thanks to Dave as well.
Thanks, that's been great.
So that's all from Egton Brook near Northampton. And it's back to you in the studio, and there'll be some more fantastic kitchen science next week. Goodbye.
Thank you, Derek. Thank you, Dave. And well done, Sam and Sebastian. Right, let's congratulate Michael, who's in Norfolk. Hello, Michael.
Hello.
Well done. You got the answer correct.
Thank you very much.
So you're walking away with tonight's Star Prize, which is the Encyclopaedia Britannica on DVD, unless Sophie, who's in St Clement's, trumps you to 3 out of 3 on Fact or Fiction. Thank you very much for taking part.
All right.
All right, you'll have to listen to the next couple of minutes and see if she beats you.
Will do.
All right.
Thank you very much.
Thanks for your call, Michael.
Bye.
And well done for winning Kitchen Science this week.
Thank you.
Next week, then, Dave and Derek will be splitting water to make hydrogen and oxygen, a process called electrolysis, and then detonating it to make a nice big explosion. So tune in for Kitchen Science on The Naked Scientist next week. Let's catch up with Sophie. Hello, Sophie.
Hello.
Right, we're going to have to be very quick because we're short for time, OK? You've got to get 3 out of 3 to win.
Okay.
OK, otherwise you're going away with one of our sort of second prizes.
All right.
You cannot hum for more than 3 seconds whilst holding your nose, and you're allowed to try it. True or false?
No, you can't do it. False. I think it's false.
You can't do it.
Oh, I think you can. Can't. Did I get that right?
Oh, I have a point.
Build up and pressure inside your nose brings the hum to a halt after a second or so.
Yeah, that's what happened to me.
Yeah, sure, yeah. Well, you were good enough to try it, so okay.
Yeah.
The cube root of 9 is 3. The cube root of 9 is 3. Fact or fiction?
Fact.
I think you actually slipped up a little bit there.
3 is the square root of 9.
Square root, sorry.
Okay, you could be still going away with something. Are you ready?
All right.
Kangaroos can bounce along at 40 miles an hour. Fact or fiction?
Fact.
Well done. They hop along at, 40 miles per hour.
Well done.
Thank you.
You got 2 out of 3, Sophie. That's great.
Yeah.
All right, so you've got something.
Thank you.
All right, then. Take care. Thanks for trying.
Yeah, thanks a lot.
It's great having you on the programme, all right?
Thanks a lot. Bye.
Cheers. Our winners this evening for Fact or Fiction, we have Rebecca in Hemel Hempstead, James in Ipswich, Catherine in Ashwell, and Michael, of course, won our kitchen. He's got our Star Prize this evening for doing our experiment at home and making a homemade fire extinguisher, and Sophie is also now in the winner's bag. Other people who got Kitchen Science correct, Richard in Ashworth rang in with the correct answer, Jenny was in Witton, and Maggie was in Norfolk. It's been a huge pleasure having you taking part in our programme this evening. Thank you very much for giving up your evening and having a go at our experiment and listening into the show. I'd like to say a huge thank you also to Dr. John Emsley, who came in and talked chemistry of fireworks this evening. So thank you very much, John.
Yeah,
it's always a pleasure to have you here. Thank you to Catherine, who co-presented this evening. Great to have you here.
Cheers.
And thank you to the Naked Scientist production team, Petro Minch and Anna Lacey. And also Holly came in this evening to help on the phone, so thank you to them. Now, next week, if you have an allergy, then it's good news, because David Pritchard, who's from the University of Nottingham, will be here to tell you how giving yourself a worm infection could actually help to make your allergies a little bit better. They're infecting people with a parasite known as a hookworm, and this seems to have an impact on suppressing your immune system and making allergies, and especially hay fever and asthma, much better. So if you'd like to find out a bit more about that, that's The Naked Scientist at 6 o'clock next week. Also, I should flag up that coming up in the future will also be, of course, doing the world's most fantastic genetics experiment. That's coming up in a couple of weeks' time. We're going to be genetically fingerprinting all around the region. And if you want to know a bit more about that, nakedscientist.com is our website, and we'll be discussing it on our forum, nakedscientist.com/forum. I'll be back on Thursday evening on the Eastern region on Nick Lawrence's programme between 8 and 8:30, taking any science questions that you might have for me. You can just phone in, unplugged, and we'll give you the answers to any science questions that you might want answered. I have a question from Tara, who wants to know about gravity. I'm a little bit short for time this week, so I'm going to do that for you next week, Tara. You are, of course, listening to the Naked Scientist podcast, which is freely available from the nakedscientist.com website. We're very grateful to Anne Gray from sciencesleuth.co.uk, who donated this week's prize. More fun and frolics available from her website, sciencesleuth.co.uk. The other big prize on tonight's show was the 2006 Encyclopaedia Britannica DVD, which was kindly donated by Band and Brown Communications. Don't worry if you didn't win it this week, as there'll be one up for grabs on every single show until Christmas time. So if you want to have a go at winning it, just send me an email, chris@nakedscientist.com, with your questions. Now, another reason to drop me a line is to take part in a new feature for The Naked Scientist, because we want your science podcasts to include in our podcast and our science radio show. The guy who's going to be sorting it all out with Petro's podcast picks is Naked Scientist producer Petro Minch. Petro, what are you looking for?
Well, Chris, we're looking for, obviously, science-based podcasts, and we're offering podcast listeners the chance of their podcast being included in our podcast, which I think is a first. So we'd like podcasts maximum length of 1.5 minutes. If it's any longer, we will listen to it, but obviously, depending on how many we get, it might take a while.
And obviously, we want them to be preferably funny, and they have to be something scientific. So if you're going somewhere exciting that's scientifically relevant, to the top of a volcano or perhaps to the bottom of the ocean, get recording and then send it to us. Chris@nakedscientist.com. Petro will have a listen to it, and the best ones will make it not only into the Naked Scientist podcast, but onto the Naked Scientist live science radio show each week. So get recording now and send them to chris@nakedscientist.com.
Sorting out the sparks from the quarks. The Naked Scientists. For more information, get online at nakedscientist.com.